Hello and welcome to the Core Learning. Today we're diving into a full walkthrough of the November 2024 AQA GCSE Maths Higher Paper 1 non-calculator. Make sure you're ready to learn, and if you enjoy the content, don't forget to like and subscribe for more detailed walkthroughs and tutorials. Let's get started.
So to start with question 1, we have work out the value of 1.5 squared. Now I know this is the first question, but this is the kind of thing that used to confuse me a little bit or throw me. So there's two ways I like to do this. One is to convert this value to a fraction, in which case we'd have 3 over 2 squared, which equals 9 over 4. And I happen to know that 9 over 4 is 2.25. Alternatively, and probably the way I actually slightly prefer, is to write 1.5 as 1 plus 0.5 times 1 plus 0.5, and then work it out as multiplying brackets, in which case, we multiply this by this. So if we go through that, we get 1 times 1 is 1, plus 1 times 0.5, which is 0.5. I'm going to have to go on to the next line, and then we have 0.5 times 1, which is 0.5, plus 0.5 times 0.5, which is 0.25. And if we add all those together, you'll see again, we get 2.25. So a little bit long-winded for a first question, but might actually be quite useful. Moving on to part 2, and we have this number machine where we input x and we output y, and we want to find the steps in between. So we're told that we have the equation y equals 4x plus 5. So how do we go from our input of x to y? Well, this is quite simple because we can see we're going to multiply by 4 and then add 5, and that is how we get y. For part B, we have that y is equal to 3x minus 24. Now, what makes this slightly tricky is that we can see that we have a first step and then we have multiplied by 3. Now, obviously, an easy way of doing this would be x multiplied by 3 minus 24 equals y. But in this case, how do we go from x to y if our first step is to multiply if our second step is to multiply everything by 3? Well, the answer is to subtract 8. If we have x minus 8 and we multiply that by 3, we get 3x minus 24. So just have to be careful on that second one. Lastly, complete this number machine so that y equals x. Well, if we multiply x by 6, then for x to equal y, we have to immediately divide by 6. Question 3, and we're told that each number in a list is increased by 10, and we have to tick one box for each statement. So we've got the mode is increased by 10, the median is increased by 10, the range is increased by 10. I think probably the easiest way to think about this is just to write out a list of numbers. So let's say we have 1, 3, 5, 8, 9, 10, 10, 11. So what would the mode be in this list? Well, the mode is just the most common number, right? So it's going to be 10. So if each number in the list is increased by 10, so 1 becomes 11, 3 becomes 13, so on and so on, the mode is now going to become 20, isn't it? So the mode went from being 10 to being 20. So in this case, the mode is increased by 10. Well, that is true. The median is increased by 10. So let me just sort out my eraser first. So let's just get rid of this here. Well, what would the median be? Median is the middle number. So in this case, I've done 4 numbers. So the median would be 8.5. It's between 8 and 9. So if every number is increased by 10, then the median would go from being between 8 and 9 to being between 18 and 19, which would be 18.5. So again, the median would have increased by 10. Lastly, we have the range is increased by 10. So again, the range, we just have to focus on our highest and our lowest number, and it's just the difference between those two. So 1 would become 11, because remember we're adding 10 to everything, and 11 would become 21. So the difference between 1 and 11 is 10. That's the current range. Add 10 to everything, and it's the difference between 11 and 21, which is still 10. So the range is increased by 10, false. Moving on to part 4, and we have to write the missing term in the geometric progression. So just a reminder, a geometric progression, we have a common factor that we multiply successive numbers by. So in this case, to go from 1 to 4, we multiply by 4, and just to, oh, we're still on eraser. So we'll multiply by 4. To go from 4 to 16, again, we multiply by 4. So all we have to do here is multiply 16 by 4 to get the missing value, and 16 times 4 is 64. And just to check, that's not what I meant to do, just to check, what's 64 times 4 is 256. So that's how we can check that this still works. Moving on to part B, and we're given a Fibonacci type sequence that begins 5 minus 9. So yeah, I mean, it says it here, any Fibonacci sequence, you add the previous two values together to get the next value. So in this case, we add 5 to minus 9, and that will give us the next value, which is minus 4. I had to think there for a second. And then we're going to add minus 9 and minus 4, which is minus 13. So those will be the next two terms, which I'll write here. Question 5, and we are given a solid prism and asked how many faces it has. So you can see we have the two faces at either end, so that's 2, and then it's got 1, 2, 3, 4, 5, 6 sides, so that's going to be 6 faces for each side. So the total is the 2 on either side plus the other 6 faces, so we have 8. For part B, we're told that the prism has a volume of 3,500 centimetres cubed and a length of 20 centimetres, and we want to work out the area of the cross-section of the prism. So let me just get rid of this quickly. So when it asks about a cross-section, what you've just got to imagine is that you take a giant knife, let's say to the middle of this prism, and you just cut through it. You just take a slice through the middle of the object. And we want to know what the area of that cross-section is. Well, if we know that the volume is 3,500 centimetres cubed and the length is 20 centimetres, then we can just divide the volume by the length to find the cross-sectional area. So in this case, it's going to be 3,500, and I'll just write in the units to be consistent, over 20 centimetres. So let's just cancel out some zeros. 350 over 2. We get 175 centimetres squared. I find this to be a good little trick as well. If you're given, for instance, in this case, a volume and a length, and you know that you want to find an area, you can kind of use the units you're given to work out maybe what you have to do. So in this case, we know that the answer we're looking for is in centimetres squared. Well, if we have centimetres cubed and centimetres, then we just divide centimetres cubed by centimetres to give us centimetres cubed, which in this case is 3,500 divided by 20. So if you're ever stuck, if there's a way you can find to make the units fit, that's usually the way they're going to want you to go. So the answer to this is 175. Moving on to question 6, and we're told to work out 1 1/5 minus 3 over 10. So we need to convert both these fractions into the same type. So we can see on the left-hand side we have a mixed number, and on the left we just have a normal fraction. So, I should say a proper fraction. So what we want to do here is convert the left-hand side to a proper fraction from a mixed number. So the way we do this, the way I like to do this is we have 1 1/5. So I want to write 1 as something over 5 plus 1 over 5. So I could rewrite this as 5 over 5 plus 1 over 5, and that's the same as 1 1/5, which is 6 over 5. So if we rewrite that in its entirety, we have 6 over 5 minus 3 over 10. Now we need to find a common denominator, which pretty clearly is going to be 10. So if we multiply top and bottom of this fraction here, so we have times 2 times 2, we get 12 over 10 minus 3 over 10. And now that we have a common denominator, we can just do the sum in the numerator. So that becomes 12 minus 3 is 9. So our answer becomes 9 over 10. Moving on to question 7, and we're given a large circle and a small circle within it. We're told the radius of the large circle is 12 centimeters, and we're told that the ratio between the radius of the large circle and the radius of the small circle is 4:1, i.e. the radius of the large circle is 4 times bigger than the radius of the small circle. And we want to work out the shaded area. So the shaded area is going to be given by the area of the large circle. So I'm going to call this A sub LC minus the area of the small circle, which I'm going to call A sub SC, and that equals, I'm going to call it A sub R area remaining. Maybe not the best terminology I've used there. So we're told that the radius of the large circle is 12 centimeters. So the area of the large circle, the area of a circle is pi r squared, isn't it? So it's going to be pi times 12 squared. And I'll just put that in brackets to make it clear that we that we square the radius first before multiplying by pi. So this is going to be equal to 144 pi. The area of the small circle is going to be equal to pi times, well, we know that the radius is 4 times smaller than 12, which is 3. So it's going to be pi times 3 squared, which is 9 pi. Therefore, the shaded area is 144 pi minus 9 pi, and that's the area remaining, and that is equal to 135 pi centimeters squared. And just a reminder that the question says give your answer in terms of pi, so we can just leave it in this form. Moving on to question 8. In this part, assume that each person works at the same rate. 10 people can complete a job in 9 hours. If 15 people work on the same job, how many hours will it take to complete the job? What we want to know here is, if everyone works at the same rate, we want to work out the amount of work in total that's being done, and then find out how long it would take 15 people to do the same amount of work. So what I'm going to introduce is a concept called person hours. So in person hours, if we have 10 people and they can do a job in 9 hours, that means the amount of work they can do is 10 times 9, which equals 90 person hours, which I'm just going to call PH. So the question now is, if we want to work out how many hours it will take to complete the job with 15 people, we simply just have to divide 90 by 15. And I'm going to leave in the units because I made a remark before about sometimes how you can use the units to work out what you need to do. So if we have 90 person hours of work and we have 15 persons, to have an answer remaining that is in the units hours, we need to divide 90 by 15. So you can see that these cancel out and we get 6 hours. Moving on to part B, we're told that of the 15 people, 6 work at a slower rate, 9 work at a faster rate. And we're asked, what does this mean about the number of hours it will take to complete the job? Unless we know the rate of the people, then it's not possible to say if it's going to be faster or slower than the answer in part A. Moving on to question 9, and we're told to work out the values of A and B. So we can see from the notation here that these are written in vector form, where we'd have an X and a Y. So how this works is the top line has to be consistent and the bottom line will have to be consistent. So what do I mean by that? A plus 1 equals 5 and 2 plus 3b equals 20. So these are the two equations that we need to work out. Well, a plus 1 equals 5 means a must be equal to 4. If we work through the second one, we have that 3b is going to be equal to, if we subtract 2 from both sides, we get 3b equals 18. And then if we divide both sides by 3, we get that b is equal to 6. And that is our answer. Moving on to question 10, and we're told that Clive owns 2 coffee shops, A and B, and of 150 people who presumably asked about their coffee shop usage, 18 people said they use both shops, 46% said they use shop A, and 2 out of 5 use shop B only. And we're asked to complete the Venn diagram. So the easiest place to start here is that we're told 18 people use both shops. So we can immediately fill in the middle of this Venn diagram. We're then told that 2/5 use shop B only. So we just have to work out what 2/5 of 150 is. So if we do 2 over 5 times 150, well, 150 divided by 5 is 30, times 2 is 60. So 60 people use shop B. And then we're told that 46% of people use shop A. So what we have to remember when it says this is just because this is not people who use shop A only, this is people who use shop A only plus people who use shop A and shop B. So what we want to do first, let's work out 46% of 150, and that is going to be 150 times 0.46. Oopsie, 150 times 0.46. Well, as it's a non-calculated paper, how can we work this out? Well, we can do it. We can work out what 10% of 150 is, which is 150 times 0.1. So let me just rub that out, actually. Or let me just write this below. So it's the same as 150 times 0.1. And we know that that is equal to 15. And then we can times that by 46. Or rather, 4.6, I should say. In fact, no, that's probably not the best way of doing it, actually. We want to work out 150 times 0.01, which is equal to 1.5, and then we do 1.5 times 46. So if we do 1.5 times 46, again, it might take a little bit of time to work out, but 1.5 times 4 is 6, times 10 is 60, and then 6 times 1.5 is 9, so we get 60 plus 9, 69. Again, you can work that out whichever way you want. I just did that off the top of my head. So what we're saying here, though, and I'm just going to rub this out just so I've got a little bit of room to play with. So I'll just write that in, so that's 69. What that's saying is, it's, let's say, we'll just say A, so people who just use shop A, plus people who use shop A and shop B, which is 18. So A plus 18 equals 69. So to work out just people who use shop A, if we subtract 18 from both sides, we get 51. So we can put the 51 in here. And now remaining at the bottom, this is going to be people who use neither shop A or shop B. So if we add up the total here, we get 51 plus 18 plus 60. And that is going to give us 69 plus 60, which is 129. We know there are 150 respondents, so I apologise, it's getting a bit messy. So the total people that didn't use either shop is 150 minus 129, which is 21. So for question 11, we're told to construct the region that lies within 4 centimetres of the line. So I don't have access to a ruler, so I'm just going to kind of do this roughly. But what you want to do is, if we start at each end, if you measure up with your ruler, and you want to measure up, obviously 4 centimetres. So for the purposes of this, I'm just going to make the mark here, and then you want to measure up. Apologies, I don't know what that was. You want to measure up 4 centimetres here as well. And I'll make a mark that should be the same. So it should be the same distance from the original line to both of these points in the vertical direction. So let's just do that. We do the same going down as well. I'm not going to draw it for this one, but let's put it here. Let me just get rid of these arrows. So again, I'm saying the distance from the line to here should be the same from the distance from the line down here as well. Again, I don't have a ruler, so obviously this might be slightly inaccurate. And then the key thing to note here is that for it to be the same distance, once we get to the point at the end of the line, So we basically have a box right now, but what we need on the end is going to be a semicircle. So the way you would do this is if you had a compass, you would set it to 4 centimeters, and then starting from this point here, you would do a line out coming to this point, and then a line out coming to this point, and the same on the other side. So this is roughly what it should look like. Obviously, this is quite difficult to do online rather than on the actual paper itself, but that is how you would approach the question. So moving on to question 12, and we're asked to convert 27 over 11 to a recurring decimal. So the way I would do this is we start off at a high level with 27 over 11, which gives us a value of 2 and a remainder, which I'm going to call little r, of 5. So 11 times 2 is 22, and then we have a remainder of 5. So the next question becomes, what is 5 divided by 11? And we get, well, 11 goes into 5, it's going to be 0.4 with a remainder of, so 0.4 times 11 is 4.4, and then we have a remainder of 0.6. And then if we do 0.6 divided by 11, so this is going to give us 0.0 and then 5. So 0.05 times 11 is 0.55, which gives us a remainder of 0.05. And then we'd have 0.05 over 11. Now, we don't actually need to do this step because we can see now that it's going to keep iterating back and forth between 5 and 6. So what we have here is going to be 2.45, and we put the 2 solid dots over each number because they keep repeating, both of them keep repeating, so it's going to be 2.454545 infinitely. For part B, we're asked to convert 0.15 to a fraction. So the way we're going to go about this is we're going to call R 0.15, and I'm going to call 100R, well, 100R is 100 times this number. So what's 100 times 0.15 reoccurring? It's going to be 15.5 reoccurring. And then I'm going to work out what 10R is. So 10R is going to be 1.5 reoccurring. And then if I work out 100R minus 10R, that's going to give me 15.5 reoccurring minus 1.5 reoccurring. And what you'll notice here is we can get rid of this reoccurring number, so we're just left with 15 minus 1, which is 14. So we have 90R equals 14, which means R, so remember R is the fraction at the start, so R written in terms of a fraction is going to be 14 divided by 90, and then if we divide both sides by 2, if we divide top and bottom by 2, I should say, which I'll just write, divided by 2, is equal to 7 over 45, which is our answer. Moving on to question 13. By rounding each number to one significant figure, estimate the value of root 401 plus 1.9 cubed over cos 58.7. So, I'm actually going to write this below because it's going to be a little bit easier. So if we rewrite this to one significant figure, 401 is going to become 400, 1.9 is going to become 2, and cosine of 58.7 is going to become cos of 60. And what we get here, well, it's going to be root 400 is 20, 2 cubed is 8, and cosine of 60 is equal to 0.5. And so we get 28 over 0.5, which is the same as 28 times 2, which is 56. Part B, we're shown a triangle. We're told that Sam attempts to find the value of cosine of x using the cosine rule, and we're shown his work in, and we're told to identify 2 errors Sam has made. I guess the place to start would be just to remind ourselves of what the cosine rule is. So if we have a side A squared, it's equal to b squared plus c squared, where b and c are the other sides of the triangle, minus 2 times b times c cosine, whoops, don't know what happened there, cosine of A, where A is the angle opposite the side A. So does Sam follow this equation? So if he has side A as 5, and then we'll say that he said this is side B and this is side C. So we have A squared, we have 5 squared equals 3 squared plus 7 squared plus 2 times 3 times 7 times cos x. So we can see that the issue here occurs with this plus between the 7 squared and the 2. It should be 3 squared plus 7 squared minus 2 times 3 times 7 times cos x. So this is his first mistake. His second mistake is we can see that he has 5 squared equals 10 squared. So he's gotten this 10 squared by assuming that 3 squared plus 7 squared is the same as 10 squared. That is absolutely not the case. So this is also incorrect. So we have a squared equals b squared plus c squared minus 2bc cos a, not a squared equals b squared plus c squared plus 2bc cos a. I apologise, I don't know what's happening to my pen at the moment. And then we also have that, well, if we have 2 squared numbers, I'm not going to call them A, actually. You know, if we have x squared plus y squared, it does not equal x plus y squared. Moving on to question 14. Enlarge triangle PQR by a scale factor of minus 1/3 with centre 0, 0. So if we're enlarging by a scalar factor of minus 1/3, then it's going to shrink and also be reflected around the point 0, 0. So let's just take our PQR coordinates to begin with. So if we have the coordinates of P as 0, 9, we have the coordinates of Q. We have the coordinates of Q as x is 9, y is 9. And we have the coordinates of R as x is 9, y is 3. And we want to work out these new coordinates. So we're going to times each value by minus 1/3. So 0 remains as 0. If we multiply 9 by minus 1/3, we get minus 3. For Q, 9 times minus 1/3 is minus 3. So we get the new coordinate, Q coordinate is minus 3, minus 3. And our new R coordinate is going to be minus 3, minus 1. And now we just need to plot that. So let's plot our new P coordinate first. So we have x is 0, y is minus 3. So it's going to start there. Should mark it with an x. Our new Q coordinate is going to be minus 3, minus 3, which is here. And our new R coordinate is going to be minus 3, minus 1, which occurs here. So, and again, I'm not using a ruler. In your actual exam, please do use a ruler. For question 15, we're told to solve the inequality 20 minus 5x is equal to or less than 30. So what we can do here is we can subtract minus 5x from both sides. Oh, rather, we can add 5x to both sides. So we get 20 is less than or equal to 30 plus 5x. We can then subtract 30 from both sides, and we get minus 10 is less than or equal to 5x. And then if we divide both sides by 5, we get minus 2 is less than or equal to x. So if we were to write that with x first, which we usually do, that would be x is greater than or equal to minus 2. And for part B, we're asked to represent x is greater than minus 1 on a number line. So the way we would do this is we draw a circle over minus 1, and if x is greater than minus 1, then it's going to be an arrow going in this direction. Now, the hollow circle means that it's not inclusive of the number it's over. So that does not include minus 1. X cannot be minus 1, that it can be anything greater than minus 1. If it was a solid circle over minus 1, that would mean it would be equal to minus 1 or greater. So just be careful of that distinction. For question 16, actually, we'll stay here. For question 16, when W is truncated, the answer is 8. Sasha writes the error interval due to truncation as W is greater than or equal to 7.5 and less than 8.5. Why is Sasha wrong and state the correct error interval for W? So in this case, what Sasha has done here, he has mistaken truncation for rounding. So if we were to round, and the answer is 8, then this would be the correct interval. Truncation, however, is where we just remove digits from the end of a number and keep the first digit. So what do I mean by that? If we had, 8,150, if we were to truncate it, we could truncate it so it becomes 8,000, where we just keep the first digit and basically turn everything else into zeros. So in this case, if we had 8.99999 and we were to truncate it, that would still be equal to 8. If we have anything that begins with 9, then it simply cannot truncate to 8. So in this actual case, the correct error interval is going to be W is equal to or greater than 8 and less than 9. So moving on to question 17, we're told that a circle has centre 0, 0 and a circumference of 36 pi. So for this we need to know the general equation of a circle, which is x squared plus y squared equals r squared, where r is the radius. So using the circumference of a circle, the circumference is given by 2 pi r, and we're told in this case that it's 36 pi. So we need to work out what r is, so we can cancel out the pi's, divide both sides by 2, and we get that r is equal to 18, which I'm going to write up here. So the equation is going to become x squared plus y squared equals 18 squared. I'm going to rewrite that because that is a dreadful looking 18. 18 squared. If you want, you can also just put in 18 squared itself, like the actual value. I'm just going to leave it as 18 squared though. For part B, point J has coordinates 15, 0 and point K has coordinates 30, minus 5. And we want to work out the equation of the straight line through J and K. Well, the way we do this is we start off with our straight line equation, which is y equals mx plus c. So we know what we're trying to solve here. So what we want to do, first of all, let's try and work out this m, which is the gradient. So we know this is given by y2, this is given by y2 minus y1 over x2 minus x1. And I'm just going to assign these now. So if we say that j is the first set of coordinates and k is the second set of coordinates, then this would be x1, y1, and this would be x2, y2. And if we plug those values in, we have minus 5 minus 0 over 30 minus 15. And that gives us a gradient of minus 5 over 2 minus 5 over 15, which is, so minus 5 over 15. If we divide top and bottom by 5, we get minus 1 over 3. So now we plug this back into our straight line equation. So we have y equals minus a third x plus c. And if we plug any two of our xy pairs in, we get, let's go for the first one. So we have 0, so y equals 0 equals minus a third times x, which in this case would be 15, plus c. And I'll just continue this down here. So minus a third times 15, well, that's going to be equal to minus 5. So we have 0 equals minus 5 plus c. And therefore, if we add 5 to both sides, we get the c is equal to 5. So our equation becomes y equals minus a third x plus 5. And let's just use our other coordinate just to confirm that's true. So our other coordinate, 30 minus 5. So if we have x equal to 30, 30 times minus a third is minus 10, plus 5 is equal to minus 5, and that is the value of y that we are expecting. So that is going to be our answer. Moving on to question 18, we're told to express x squared plus 8x minus 5 in the form x plus a squared minus b. So this is the difference of two squares. So the way we're going to do this is we take half of the x term, which is 4. So we have x plus 4 squared. And this is equal to x squared plus 8x plus 16. So what we want to work out is how do we go from x squared plus 8x plus 16 to get to x squared plus 8x minus 5. So the easiest way to do this, we have x squared plus 8x plus 16. And let's have this term on the end, call it whatever you want, let's call it a, plus a equals x squared plus 8x minus 5. And we want to work out what this a term is, because if you remember, this is the same as that. So we just want to know what goes on the end of that for it to be the same as this. No. To be the same as this. So working this through, we can cancel out the like terms, and we're left with 16 plus a equals minus 5, therefore a is going to be minus 5 minus 16. So a is going to be minus 21. So our final answer is x plus 4 all squared minus 21. For part B, we're told that a curve has the equation y equals x minus 7 squared plus 8. We want to write down the coordinates of the turning point of the curve. So if we think about an x squared curve, I'm not drawing specifically the one we have, but just roughly, we know that it's this U-shaped curve. So the turning point is going to be the lowest point that we have. So in this case, the lowest point is going to occur when y is the lowest value. Now y is going to be the lowest value when x equals 7, because any value other than 7, it's going to be greater than 8, isn't it? Because even if, for instance, we had minus x is minus 1 minus 7 is minus 8 squared would be 64 plus 8. So the lowest value of y we can have is when x equals 7. And consequently, when x equals 7, 7 minus 7 is 0, squared is 0, plus 8. So y is going to be equal to 8. So moving on to question 19, and we have this triple bracket expression that we want to simplify. So the easiest way to do this is to start with two brackets and work those through. So in this case, we'd have we'd have x plus 2, 2x plus 3, and then we just need to make sure we multiply each term, and this would give us, so we have x times 2x, that's 2x squared. We have x times 3 is 3x. Then we have 2 times 2x is 4x. And then we have 2 times 3 is 6. And now we want to multiply this with the next bracket. In fact, let's simplify first. So we have these middle terms, 3x plus 4x, we can simplify that as 7x. And now let's multiply that by 3x plus 4. And again, just making sure, I always just like to draw these arrows just to make sure I'm remembering to do each set of terms. So again, if we start off, we have 2x squared times 3x, that is equal to 6x cubed. And then we have 2x squared times 4, and that is 8x squared. Then we have 7x times 3x, which is 21x squared. And then we have 7x times 4, which is 28x. Probably going to have to go on to the next line. Lastly, we have 6 times 3x, which is 18x. And then we have 6 times 4, which is plus 24. And then we just need to simplify this, so we can just add together our like terms. So in this case, we only have one x cubed, so that just stays as 6x cubed. And then we have two x squared terms, so we have 8x squared plus 21x squared, which gives us 29x squared. We have two lots of the x term, which is 28x plus 18x, so that gives us 46x. And then we just have one number term at the end, which is plus 24. I'm not going to rewrite that, but that is our answer. And then we're told that using our answer from part A, we want to work out 102 times 203 times 304. So in this case, if we have 102 times 203 times 304, this would be the case where x is equal to 100. So if we were to make x equal to 100 and go back to the top line here, 100 plus 2 is 102. 2 times 100 is 200 plus 3 is 203. 3 times 100 is 300 plus 4 is 304. So we can use this expression here and just substitute in 100. So this would be equal to 6 times 100 cubed plus 29 times 100 squared plus 46 times 100 plus 24. And that is going to be equal to, well, 100 cubed is going to be 6 times, it's going to be 6 times a million plus 29 times 10,000 plus 46 times 100, which is going to be 4,600 plus 24. So that is going to give us 6,029,000 times 10,000 is 290,000. So 6,294,624 when we add all that together. Moving on to part 20, show that root 363 over root 3 simplifies to an integer. So the way we are going to work this out is to break this down in terms of the prime numbers. So we can leave root 3 on the bottom. The question is, how can we break down root 363? As a reminder, if we have root a b, that is the same as root a root b. So do we have two things that multiply together to give 363? Well, yeah, obviously we know that 3 and 120, so, well, sorry, we know that 3 and 120 give 360, so 3 and 121. So we can rewrite this as root 3 times 121 over root 3, which equals root 3 root 121. So we can cancel out our root 3's, and we're left with root 121, and root 121 is 11. Moving on to part B, we're told to rationalise the denominator and simplify. So the way we do this, if we start off with 20 over root 5, and what we're going to do is we're going to times top and bottom by this value. So when it says rationalise the denominator, what we're trying to do is get rid of this third on the bottom. So by multiplying by another root, we just get the number inside the root. So we get 20 root 5 over 5, and we can just work out 20 over 5 is 4, so the answer becomes 4 root 5. So moving on to question 21, and we have a y equals tan x graph here, where our values are between 0 and 360 degrees. So we're given that tan of 78.69 degrees is equal to 5, and we want to work out the other value of x, where tan x equals 5 between 0 and 360. So the first thing I'm going to do is just draw a line from 5, so it's not the best line in the world. So if I come down here, you can see this will be, and I've not really got the room to draw it, but where the line that I've just drawn meets the x-axis, this is going to be 78.69 degrees, and we want to find the other place where this is true. Well, you can see that the dotted line meets the graph again here, and the thing about tan x graphs is that they are symmetrical and repeat every 180 degrees, as you can probably see there. So to work out the answer for part A, we just need to add 180 degrees to our first point, and that's going to give us 258.69 degrees. For part B, we're told to work out the two values of x where tan x equals minus 5, and again we're between 0 and 360 degrees. So the way we can do this is again using the fact that it repeats and the fact that it is symmetrical. So what we can say is that if we know that tan of 78.69 degrees equals 5, then tan of minus 78.69 degrees equals minus 5, and from there we can just use the fact that we know that it will repeat every 180 degrees, and I'll probably just draw this not like that there because that wasn't a good line. Try and draw it so it roughly meets up. So if we were to continue this line, it would look something like that with an asymptote, and again this is not done particularly well to scale, but this point here would be minus 90 degrees, and therefore it would meet the graph for minus 5 at minus 78.69 degrees. So our first answer is going to be minus 78.69 plus 180, and that is going to give us 101.31 degrees, and then we just add 180 to that to get our second solution, which is going to be 281.31. I think that looks correct. Yep, looks fine to me. So these will be our two solutions for part B. Moving on to question 22, and we can see that we've got this expression 7 to the power of n equals x, and then we just have to match up each expression on the left to each expression on the right. So the key here, we only need to remember two things about indices to make this work. So as a general rule, x to the power of a times x to the power of b equals x to the power of a times b, and x to the power of a to the power of b is, excuse me, that's not correct. X to the power of a times x to the power of b is x to the power of a plus b, and x to the power of a to the power of b is x to the power of ab. So I'll do it down here. So if we have 7 to the power of n equals x, so working from the first one, well, 7 to the power of minus n is the same as 7 to the n times 7 to the n to the power of minus 1, I should say. So if we do both sides to the power of minus 1, what we then get is that 7 to the power of minus n equals x to the minus 1, and anything to the power of minus 1 is 1 over that value. So that's why we can see we've got the first one there. So let me just rub that out. So that's just proving that the first one, it's proving how we would work out the first one, but it's already been done for us. So for the second one, and again, I'll just have this 7 to the n equals x. How do we get from 7 to the n to 7 to the 2n? Well, if we look at our rules above, then using this x to the power of a to the power of b, we get x to the power of ab. So if we just square both sides, this will give us 7 to the power of 2n equals x squared, which I'll just link up there. So again, let's cross that out and do the next one. So we have 7 to the power of n plus 1. So again, we can see this time we can use this rule here. So if we have 7 to the n times 7 to the power of 1, so again, we have to apply this to both sides equally. This will give us, on the left-hand side, 7 to the power of n plus 1 equals 7x. And lastly, we have 7 to the power of half n. So again here, if we look at our bottom rule, I'll just get rid of that. If we look at our bottom rule here, if we make b in this instance equal to a half, we have 7 to the power of n to the power of a half equals x to the power of a half. And so we'd get 7 to the power of half n equals x to the power of half. Anything to the power of a half is the same as the square root of that value. So this would be root x. And moving on to the last question, question 23, and we're given this y equals x squared graph, and we're told to write down the equation of the graph shown. So one way I like to do this if you're ever struggling is let's just plot the original graph. So y equals x squared. So when x is 0, y is 0. So I'll just plot that. When x is 1, y is 1. When x is 2, y is 4. Now, we could plot the other side. You don't even need to do this. If we compare each coordinate to the new coordinate, what do we notice? We notice that each coordinate is now shifted up by 2. So y has increased by 2. So the equation of the graph is going to be y equals x squared. So, y equals x squared, which originally is 0. And then to get it to its new coordinate, you have to add 2. So that's just an easy way to work that out. For part B, we're told to write down the equation of this graph, which is reflected in the x-axis. So in this case, y equals, well, again, we could do the same thing as we did before, but if we know that originally if we know that it's a reflection, then every value of y that we previously had, it's just going to be the negative value of y. So we have y equals x squared, and then it's just negative. So it will be y equals minus x squared. Part C, write down the equation of the graph shown. So in this instance, we can see that it looks like the graph has been shifted 3 places to the right. So again, if we have y equals x squared, and originally, when x was equal to 0, y was equal to 0. Now, when x is equal to 3, y is equal to 0. So when we do this one, we actually need to subtract whatever value we've shifted to the right. So in this case, we get y equals x minus 3 squared. And you can check that. So when x is equal to 3, which we have here, we should have that y is equal to 0. So 3 minus 3 is 0, so that checks out. When x is equal to 4, we should get that y is equal to 1, and so on. So this all checks out.
So guys, that brings an end to our video for today. Thanks so much for watching. If you found this walkthrough helpful, don't forget to hit that like button and subscribe for more GCSE Maths and English content. You can find the next paper walkthrough on the following screen. Happy studying, and see you next time.